What's up guys, this is day 63 of my DSA challenge and this is how my lead code profile looks like on day 63. So moving to the problem, we are today going to do matrix problems. So this is problem number 74, search a 2D matrix. You are given an n cross n integer matrix with following two properties. Each row is sorted in non-decreasing order. The first integer of each row is greater than the last integer of the previous row. And we are given a target, return true if the target is found in the matrix, otherwise return false. And the main condition is that we have to write the solution in big O of log of m cross n time complexity, which is kind of easy to first think when you're solving this problem for the first time. So for the example, this is the matrix containing of 3 rows and 4 columns, and the target is 3. So we have to find 3, and if it is present in the array, simply return true. So in this case, it is true. That's how it is. Moving to the optimal one, we can use binary search, as we all know that the elements are starting from like non-decreasing order. First is like the smallest element and the last is the greatest element. So hypothetically we can think like this is the sorted array. Like in the first row all the elements are sorted 7, and the second row starts with the element which is greater than the previous row's last element. So yeah, we can think of it like a sorted array, and using that logic we can simply like use binary search into it. So we are going to do start as like 0 to m cross n minus 1, because the last element will be m cross total number of rows into columns minus 1. That will be 60 in this case. So first we are going to do that, and while I is less than equal to j, find the mid element. And the key conditions is that first we can literally find the row and column by using this formula, which is mid by m for row and mid modulus m. M is the number of columns in the row in the matrix. And in case if matrix of row column is equal to target, return true. Or else if the matrix of row is less than target, like if the matrix, if the current element is less than target, we know that it is sorted array. We can move down the row. We know that it is sorted, so we can, if we move down the row, we would find element which is greater than target. That's how it will be. So that's why for this it is I plus plus, or else like move to the left part of the array. We can't use binary search because like the order is like from in the first array, in the first row it is from left to right increasing order. And talking about the column behavior, that is like from the top it is least element, and as we go down the column it keeps increasing. So it is quite different from the first part, so we can't use binary search in this question. So we would simply stick to using while loop, and in return we will get a time complexity of like almost big O of m plus n. So in this we are first going to define n and m, rows and columns, and then define row as 0 and column as m minus 1. And while the row is less than the number of rows, total rows, and the column is greater than equal to 0, we can like find it. If the current element is equal to target, return 2, or else if it is less than target, we are again going to do like move down the row, or else move to the left. And in case if it is not present, return false.